right, good morning, or whenever you're watching this. Hope the day's going well for you. I want to go through some more factoring examples and try to tie in one other idea. I didn't do much the other session with the 4-term and 2-term factoring problems, and I got something prepared for the 2-term factoring situation that we'll run into a bunch of those. So I definitely want to do that, and then I want to see what other questions come up, what other if you had any issues with the lab. I know the lab was long, redundant bunch of factoring stuff. If you're working on that already, you've seen a bunch of factoring there, mostly same steps over and over, but we need a lot of practice with that. We need a little repetition on that to get the patterns down, and they should get easier as you go along because you start to pick up on kind of the feel of the pattern of how these things go. There's one on the lab that's prime. As you're going through it, you won't be able to find numbers that work for that one because it's prime, but the rest of them do factor. You got to be careful with your GCF stuff as you go through it. Some of them have a GCF to be pulled out first, and then some factoring. It's a lot of practice with that. So if there's some of those that you're not sure about, indicate that. Put that into the chat here if you want as we go along. And I want to tie in the 2-term situation with this. So I got some examples down in that I want to get started with, and then we'll see what questions come up. There is, I think, one more test before the final. I think just one more. Our final exam is going to be more or less on schedule. It was March 8th or 9th, somewhere in there. And I think we're on schedule for that. I mean, we're going to keep those at the same time that they were planned, except we got some flexibility now because we're doing them online. So we'll probably have a few time slots available for that one also. I'm going to go to what's been sent in. Okay, thank you. Trying to remember what my whole schedule was for this deal. Okay, we have a couple of tests before then. We're going to do the rational expressions, beginning of rational expressions, and then have a test. It's keeping it around the date that it was on the original calendar. So the week of, it's next week, end of next week, we're going to take a test on that. And then we'll do the rest of rational expressions and the exponent root stuff. Quadratics, chapter 7 and 8. We'll have a test just before the final on that around May 2nd. And then the final exam is probably going to be May 8th or 9th. We're going to have a couple of time slots available there. That's the plan. So we got to get good at factoring. And one of the uses of factoring, this is going to show up early chapter 6. This week and early part of next week. Get ready for that final exam or chapter test on factoring. So the way the tests are going to work is I'm going to send a announcement out. It'll be in Monday's email. There'll be a few, or Monday's announcement. There'll be a few different time slots you can pick from, and you're going to email me and tell me which time works for you to take the test. And then at the beginning of that test period, I'm going to send out the exam paper. You'll either print them or copy them down, and then turn in your work for that at the end of the time slot. Just email back to me the pictures and scans of what you've got on the test, just like we do with the other things. They're open book tests now, kind of have to be. So I got some extra time. I'm using a 3-hour time slot, so you have time to work through them. So there'll be the chapter test on basically 5 and 6, and then 7 and 8. And then the final exam is a little bit of everything. Yeah, it covers a little bit of everything through the whole semester. All right. Let me get situated to take a look at this. I have some 2-term factoring I want to look at while I'm on this morning. So get this situated. All right, this is Calc 3 stuff, so I don't have to think about that. Somewhere in here. A bunch of two-term factoring problems to look at. There we go. A bunch of these are two-term factoring. Now, two-term questions, I want to see if we can factor them. Let me get the camera. Good. So these things don't have a middle term. That one middle term that we've had to split up into pieces and find the numbers that work with that. Well, sort of for these, that middle term is 0, and so it isn't even written on here. Really, the only way two numbers can add up to 0 is if they're opposites of each other, right? You'd have to have +4 and -4, or +6 and -6, or whatever the numbers are, opposites like that. And that turns into this kind of factoring that is the only way to do it. So that's the only kind that factors as far as two-term factoring problems. Step one is always to look for GCF first, because no matter how many terms there are, we want to take out the GCF first, but none of these have any common factors besides 1. There's nothing to be factored out as a GCF in any of these. And actually, we're going to be able to do these kind of things almost immediately, because the only way they can factor is if they fit these special forms that we're looking at. So write this down quickly, but try to convince you that this is the way that it goes. This has to be prime, because 8's not a perfect square. This says to be prime because 3 is not a perfect square, and it's a plus in here. The only way that they could factor is this kind of situation. This is going to factor because x squared and 16 are both perfect squares, and it's a minus right there. That's going to fit that difference of squares factor pattern. Difference of squares. Anything that can be written as perfect square minus a perfect square can be factored. This one is x squared, and 16 is 4 squared. So this can be written that way, so it can be factored, and the factors are going to look like x minus 4 and x plus 4. I think there's a couple of these toward the end of the lab this week that end up factoring this way. A little logic behind that. Mostly it's just recognizing this pattern, but just to give you a little the logic behind it. If you set up your box with this thing, you got a minus 16 down here, and your x terms have to add up to 0x. I don't have any x's, so these have to be exact opposites. But with +4 and -4, they add up to 0x. That's exactly what we've got. And with those kind of numbers, you have to have a minus perfect square right here in order for it to work out. And then your factors are x minus 4 and x plus 4. So that works out. And if these are not perfect squares, if that's not a minus, then this isn't going to work. It isn't going to factor at all. These are perfect squares, but that's a plus. That's prime. Doesn't work at all. These are perfect squares, and that's a minus. So this one should work. I should be able to factor this one. It's a little harder to see what the factors are. 9 and 25 are perfect squares, but I have to think this through a little bit. So there's this in-between step that you don't really have to write down, but it helps to write it down. We need to know what the pieces are that are going to go in here. So I have to write it specifically as a difference of squares. 3 squared is 9, so this is 3x squared, and 25y squared is 5y squared. Those are the individual pieces that I have in there. So that's what I need to make my factors out of. Those are what goes here. One of these is a minus then, and one of them is a plus. That's the pattern. That's the difference of squares pattern. They have to be perfect squares for that to apply. Otherwise, prime. There is similar patterns with cubes that we're going to see occasionally. So this has a different exponents. This one's prime because it's not squares or cubes. It's a mix. These are perfect cubes, but 23 is not a perfect cube number. So this one's also prime. See, the only way these can factor is if they fit these patterns. So with 23 not being a perfect cube and these being perfect cubes, prime. These are both perfect cubes. This is going to factor. This is a sum of cubes. Cubes work whether it's a minus or a plus. There's two different sort of recipes or patterns that this fits. We don't have, I can't really do this with the regular box thing because there's more terms going around in this thing. It's really a longer factoring pattern, so you just kind of have to remember the pattern to it. But anything that can be written as perfect cube plus perfect cube can be factored, and there's a short and long factor that we get from it. But we just really have to remember the recipe to it, the formula for it. This is a nice simple example because x cubed is just x cubed. 8 is 2 cubed. 2 times 2 times 2 is 8. As long as it can be written in that in-between form, it can factor. The factors, the short factor is just x plus 2, then whatever you have inside here, the plus. And then the long factor is the first one squared minus this times that plus this one squared. So that's going to be x squared minus 2x plus 4. Now that looks like it kind of came out of nowhere right there, but if you do out the multiplications on these, you can see how they work out with that, the middle terms all dropping out. This is going to have, if I multiply this all out, it would have a minus 2x squared and a plus 2x squared. So it'll give you 0x squared, which is what we have. It has a plus 4x and a minus 4x. So the x term is 0 also. It's that little pattern, that formula, that makes that come out to the nice two-term thing. So we get a short and long factor out of those. That's what we need. This one fits that same pattern because 64 here is 4 cubed. So I can write this as a sum of cubes also. 4x cubed is this, and 1 cubed is 1. So I can write that as a sum of cubes. And so I can factor it by that same pattern there. Short factor is this plus that. And the long factor is the first one squared minus this times that plus the second one squared. If they weren't perfect cubes, they wouldn't factor. But if it's the sum of cubes, it does. And if it's the difference of cubes, it does also by a slightly different pattern. So I'm going to look at one difference of cubes I had written down here also. I think we'll run into these some as we go along. All the kinds of factoring are going to show up as we go through the stuff in the next chapter. We're going to get plenty of practice with these things. Okay, this is going to be a difference of cubes right here. We got minus, so it's a difference. Subtraction difference of cubes. This, again, it's only going to work if they're perfect cubes. I have to be able to write it as something cubed minus something cubed. So x cubed minus, it's only going to work if that's a perfect cube, but it is 3 times 3 times 3 is 27. Right, so 3 cubed is 27, so I can write it as the difference of cubes. Just get that idea in there that if you had anything else sitting here, it's going to be prime. If that was anything other than a perfect cube, this would be a prime polynomial. It wouldn't factor, but with the nice perfect cubes, it will, and we'll run into those quite a bit. Since they cover this factoring pattern, they'll use it as an example in a bunch of the exercises we're going to do. Difference of cubes is almost the same. There's the short factor and the long factor. And this one is a minus this time. And all the terms over here are a plus this time. This is still the first one squared. This is this times that. And this is the second one squared. The only real difference here is that you have a minus for difference and a plus here, with the sum of cubes. If I had x cubed plus 27, if that was a plus, the difference in here would be that this is a plus, and this is a minus here. Both of them work out with those opposites that I was talking about. Your 3x squared minus 3x squared. The opposites work out either way. This one fits for the sum of cubes, and this one fits for the difference of cubes. So you kind of have to remember those two recipes when you run into something with cubes on it. Now, whenever I have a factor that still has an x squared and it still has an exponent bigger than 1 in it, I have to think, maybe I can factor this a little further. Maybe I can go further and split this up. But the one that you get out of difference of cubes is not going to. This is going to end up being prime. If you try to factor this thing, you're going to find there isn't any numbers that work with the 9 right here that add up to 3. There's no factors of 9. Well, let's just look at it this way. 9 can be written as 1 times 9 or 3 times 3. Neither of those add up to 3, right? So there's nothing to put here. This is going to make that work. So that's factored as far as it can go. It doesn't go any further. But we got to remember to ask that question when you do any kind of factoring. And one of the pieces still has an exponent in it. You got to see if you can keep going. You got to see if you can break it down and make sure that you have it factored as far as it'll go. So that was the other big situation that I didn't really get to last week. Basically, for any kind of factoring that you're doing, take out the GCF first. That's always the first step. And then from there on, you can sort it out into a few categories right here based on the number of two terms. For these two-term things, there's difference of squares, difference of cubes, sum of cubes. Otherwise, it has to be prime. It fits those. Those are the only patterns you're going to see in there. There is corresponding patterns with higher powers, but we're not going down that road. So these are the only ones that factor. Notice it can't be a sum of squares. That one doesn't work either. There's no pattern for that. That one's also prime. For three-term factoring, after you've taken out the GCF, if you see that it has either 3 or 4 terms, you're going to be able to do those with the box method stuff and work it out. So the longer factoring problems can be done that way. The box method works when there's factors that look like 2 terms. And 2 terms, then we're going to have either 3 or 4 term factoring out of that. So the regular factoring will work with the rest of those.
Oh, it's okay.
I'm trying to remember if there was any 4-term ones in the lab. Let me bring up that paper and take a look back at that, because 4-term ones I haven't done a lot of examples on the video sessions. They're built in there. I called it lab factoring with cubes. That means there probably is some of these sum and difference of cubes in there. You find them. Is there? $23, $26 on that lab. I got a bunch of these things. 23 and 26 both have those perfect cubes involved. The exponent 3 there is a giveaway. If there's no GCF and you have an exponent 3 in there, it's going to have to fit one of those prince of cubes or sum of cubes patterns. So you get some examples on that. A couple examples of that on the lab. I don't really see any 4-term factoring on there. I don't think I put any like that into the lab. So let me pull some examples on that instead while we're here. Take a minute on that. So these, we'll see occasionally a 4-term factoring thing. We want to be able to work our way through that. Four unlike terms to it. So here's an example. An example that's actually going to work out for us. Trying to factor, here's a 4-term polynomial. 2x cubed minus 5x squared plus 8x minus 20. And the first thing I ought to think about is there a GCF I can pull out from this thing? Two goes into most of those, but not the 5. So not quite. There's no number that goes into all of those. And there's x's on most of them, but not all of them. So I can't get an x out of everything. There's nothing that's in common with all 4 terms. So the GCF is 1. There's nothing to do there. So I count this off and I got a 4-term problem. I'm just hoping that it's going to fit this pattern. So I got to put these into the box. If it's a 4-term factoring, that's exactly how many things I want. Put these into the box that's there. Write them down and see what comes out as your rows and columns here. So 2x cubed minus 5x squared plus 8x minus 20. I don't have to worry about the number pattern on this thing because the middle terms, basically, they weren't unlike terms anyway. So they're two separate things instead of having a combined middle term. Notice the numbers, negative 40, these multiply to negative 40, and so do those. It tells me I'm looking good. I'm going to have the factors to this thing. Take out the GCF from the rows and columns. So across this row, you got a common factor of x squared. Across this row, I don't have any x's here. The number 4 is the common factor there. Minuses are this way. I got a column of negatives. So the minus is going to be up here. This is a plus 4, and this is a minus. Common factor here is 5. Common factor here is 2x. Those are the factors that I get out of that. So it factors into my answer here. It'll be 2x minus 5 and x squared plus 4. Now, I still have an exponent in this one. Exponent of 2, so I got to think, can I factor this any further? But this little one here is a 2-term factoring problem. And the only way it would factor is if it was a difference of squares or difference of cubes or sum of cubes, and it's not. It's actually a sum of squares, which doesn't factor any further. So I got to check that to see if it'll factor any further, but this one doesn't. X squared plus 4 is prime. There's no factors that'll work there. So I've gone as far as I can go. Those are the factors of that. So I should get through a couple of these 4-term factoring things. I just take the 4 terms and put them in. Now I just put them in the order that they were given. And sometimes you got to think about the order a little bit to get these to line up right. You do want your sort of diagonal products to be the same anyway, but it's not always obvious which way to do that. So let me run through a quick example with some other letters in it just to see what else can happen here. So I'm going to keep that example beside what we're doing. I'm going to do one more up to the side. Here we go. 2xm minus 3m plus 2xn minus 3n. So that's got different letters in it. And that shouldn't really scare you in factoring problems. The letters don't do much of anything interesting here. We got to be careful with them, but it's the numbers that make them interesting. And not much going on for numbers here. But again, the first thing to look for is GCF. I got to ask myself, is there something I can pull out of all of them, a monomial that I can pull out of all of them? It's like 2x goes into a couple of these things, but not all of them. There's no letter that shows up on every single term. So again, there's no GCF to pull out. No luck with that. GCF is 1. 4 terms, I'm just going to go ahead and put them into the box then and find stuff to pull out that way. So 2xm. I want to put something here that has an x or an m in it. I might mess with the order here a little bit because I want common factors to the rows and columns, but I want my products to work out. So I need the minus 3's down here. So I actually could put the 2xn here if I want. This should work okay. Minus 3m here, I'll have a common factor there. Minus 3n. I'm noticing that the diagonal factors, the diagonal multiplication here, this is negative 2 times negative 3 is negative 6. Negative 3 times 2 is negative 6. That should work out just fine. I don't want to put the 2's diagonal to each other. So there's some orders that wouldn't work. But putting them in this order looks good. Common factor to this row is 2x. Common factor to this row, the minuses are across here, so that's a minus. Common factor here is m. Common factor here is n. So you have your 4 terms that go in the 4 boxes. You have to be a little bit careful to put the right stuff in the right box, but there's a lot of orders that'll work out okay here. This one worked out just fine. You see the little products work out. Negative 3 times n is negative 3n. 2x times n is 2xn. Everything works out there. So those are the factors, and just got to write them out. 2x minus 3 and m plus n is the factored formula. No exponents left, so I know that's gone as far as it'll go. Everything's pulled out on that. Now I want to go ahead and think about the reason why you might care about that a little bit. We've done a whole bunch of factoring just to like write down factors and sort of feel good about the fact that we've got factors written down. It's not that we haven't talked about the reason why that would actually help us do anything yet. We're going to see a couple of places where it does. I want to work through one more and then kind of look at an example of where this factoring helps us to get something a little better. So if I start with this expression, we're going to do, coming up here, we're going to do these fractional expressions. I have something, I'm going to use that polynomial that I just had there. 2xm minus 3m plus 2xn minus 3n. I have a fraction with that polynomial and then some other polynomial down here. I just want to simplify that thing. I want to write it in simplest form, just like anytime you have a fraction back in regular arithmetic, you're asking yourself, can I write that in a simpler form than that? So we got to think back to problems like 16 over 12. And if you look at that and think, I can divide both of those by 4, you'd be right. Both of those are divisible by 4, so this is going to simplify it to just 4/3. I'd rather write it in that simplest form. That's easier to understand what that thing is, right? That's a much nicer way to write that number. And we'd like to know if there's a nicer way to write this expression without as much complicated stuff in there. But we don't want to think in terms of dividing by 4, because doing division with these things, we did a little of that last week, but it wasn't, it wasn't a nice thing to do. We want to avoid that if we can. We're not going to think of it in terms of division. We're going to think of it in terms of factors. Over here, if we just observe that you can write 16 as 4 times 4, and you can write 12 as 4 times 3, then we can get our simplest form by just doing that. I just crossed things off. That is actually division, but I do the division by just crossing things off. That's the right way to think about it. Factors, common factors that are going to cancel out. That's when this thing would simplify. So writing them in factored form is the key to all of this. So great big complicated looking thing like that. I want to rewrite everything in factored form and see if I can simplify it. Now I already did this 4-term factoring problem. So I know the factored form of that. I can rewrite that as 2x minus 3 times m plus n. This one I want to write in factored form also. So I'm going to go off to the side and see if I can find factors of this thing. I got 10x squared minus 7x minus 12. Now the 7x is going to be split up. I need numbers that add up to negative 7, but I need numbers that multiply to negative 120. Now that's quite a few choices, negative 120. There's a lot of ways to write that. So I got to think this through if it's going to add up, if there's anything that's going to add up to negative 7 here again. So this is a pretty tough one numerically. It could be 1 times negative 120. There's a lot of things that go into that evenly. So there's a lot of choices here. But I'm going to write them out for a while and see if I have any luck. 4 goes into it evenly. 5 goes into it evenly. 24 times. 6 goes into it evenly. 7 doesn't go into 120 evenly. 8 goes into it evenly. And there's the one, if you were watching for something that adds up to negative 7, you might catch it. There's not too many other choices here on this really, but this is the one that adds up to negative 7. So that's the numbers that go in my box. Those aren't the numbers that show up in the factors. They're the ones that go inside the box. And then we got to do our inside out part, taking out the GCF here and here. These are both negative, so this one's a minus 3. So we got to be real good with the little GCF things. Quicker you can do that, the better. But those are the factors. And sure enough, the factors of it are 5x plus 4 and 2x minus 3. You think, how lucky is this that we got exactly the same thing here that we got there? Well, that's doctored to look like that. But these simplify problems are going to be doctored usually so that some factors are in common like that. If we're lucky, we can get a factor that'll cancel it. That's got to be exactly the same factor. Here, I did out the division, and that factor canceled out. So the whole thing can just be written as m plus n over 5x plus 4. That's one of the nice things about factoring is you can find out if these things simplify and can be written in a simpler form. So this that we ended up with, this off camera a little bit, that whole great big fraction expression can be written in a nice shorter form like that m plus n over 5x plus 4. I don't even really need the parentheses around them anymore, but I like to write them because those are factors. But that's a simpler expression for that thing. That's one of the things we're going to do with it. Couple of cautions, I guess, as you go through. I'm looking at the ones on a lab. It looks like with the lab that I gave you the answer key page with it. So the factors are there. And you see there is one prime, one in the middle of that. So if you ran through it and got stuck on one, yeah, there is one that's prime where you can't factor it at all. But the rest of those you do find some kind of factors. One thing you have to be careful about is not going into the box if you have a GCF to do first. It'll only throw things off. So something like number 17, we got to avoid a whole lot of extra confusion by keeping track of our steps on that. Number 17 looks like, find a factor form, but it starts off as x cubed minus 24x minus 5x squared. Okay, that's tricky in a couple of different ways on this. And if you start trying to drop these into the box, you're going to get tangled up on a couple of different things here. But first thing is always to look for a GCF. That's always step one. And we're going to notice on this one, there's x's everywhere. So we have a GCF of x. That's got to be pulled out first. See what you have left now. And if we divide that x out of everything, we got x squared minus 24 minus 5x. Now, the other sort of sneaky thing about this, where it was kind of a trickier problem, is the order of those terms right there. We don't usually have the x term here and the number term there, right? And if I'm going to go put these into the box, I'm used to looking at x squared being up here and just the number being down here. And that is what I want. I want that term last. Now, the order of the terms is usually in that nice descending order. We really get used to the descending order, and we're going to rearrange it to put it in that nice descending order. Now, this one wasn't written in nice descending order, so these ended up kind of out of order. But we can rearrange the terms. They're all just terms that are combined. So we can write them in the proper order on that. And you really need to, when you go to put them into the box, this has to be your lowest degree term, your number term. Now I'm ready to go ahead and do the numbers on that. Is there something that multiplies to negative 24 and adds up to negative 5? And you might get better as you do a whole bunch of these factoring problems. You might get better at picking out these numbers without having to write as much down. But those are the two things that multiply to negative 24 and add up to negative 5. And the factors come out of it. Common factor there is 8, x minus 8, and x plus 3. So you might get quicker at seeing these as you go along. When you find these factors, if you have a GCF sitting out here, this is still part of your answer. So your completely factored form of this still has the GCF part, and then the factors that you found from your box, x plus 3 and x minus 8, show up there. That's the completely factored form of it. I don't have any exponents left, so I don't need to factor any further. That's completely done. So normally we just write things in descending order. It should be kind of your algebra instinct by now to think that should be rearranged and put into order. Factoring is one of the places where that order is really kind of important. Having it written in the normal order of these things is pretty important. So there was a couple of tricks to that one. most of the other ones on the lab are, I think everything else is written in descending order already. We just do that for convenience on this stuff. So that one was a little tricky. The other thing to make sure of is that you watch out for that GCF, to make sure you pull that GCF out first. Keep it there. If there's a GCF, keep it written there. Several on the lab that have a GCF. And your box is going to be full of too much stuff if you don't get that GCF out of the way. It won't work out nice. All right, I'm hoping that between now and Friday, let me know if there's any of these you're having issues with. It seems like a lot of redundant work. We have to get really good at this factoring before we put it to use. So it is a lot of redundant stuff. Factoring kind of similar patterns over and over again. We want to lock this in and be super good at it. If you get the factoring and you're pretty good at it, then this next couple of chapters is really going to be much easier. So getting a lot of practice on this. We'll see more of why it matters to us. Friday session, I'll move into some of the stuff coming up. But I'm also hoping to answer questions there. So if there's ones on the lab that you're stuck on that 5th online homework, that is up and running now, and some people have gotten through that. So let me know if there's any of those that you have any questions about, any uncertainty. The lab, you can kind of check your own answers, but get that turned in. You get those written up. And the 5th online homework is, I think, pretty similar exercises. They have weird ways of asking things in there sometimes. So if you're not quite understanding how you're supposed to, what they're asking for in one of those problems, let me know. I can talk about some of those during the Friday session, or I'll try to get back to you by email. I'm trying to keep up with the emails where if you submit work, I get right back to you with feedback pretty quickly, because I don't want to fall behind on this stuff and lose track of people's work. And I want to get feedback to the people that are doing the work as quickly as they can, so that stay engaged with this stuff. So during the lab, as soon as it's finished, questions on the homework, get them to me. You can put them through an email, or you can put them into the discussion things in the Blackboard course. I'm trying to keep an eye on that, see if any questions come up there. Also, hey, if you have technology issues or other kinds of life issues that are getting in the way of being able to get through your studies, college is trying to mobilize to help people out. I think we know that nobody's getting this semester that you signed up for here, and issues like that come up, we're trying to get resources together to help people out with other kinds of things that might be obstacles for you now. So I've got some connections on that. If you have something come up that is getting in your way here and outside of class stuff, there are other people to contact on the college. They're really trying to help with that. If I can point you in the right direction, I'd be glad to there. I have some of the links for that. Help with housing situations, help with counseling, help with technology issues. So let me know if anything else is getting in the way. And I'll be on Friday afternoon also for the YouTube session, and I'll be trying to get to answers in between there. I'll have a good week.